Alright, welcome guys to episode number 5 of Made with Quantum. Christian, what is this big thing on the table?
Alright, this is a AM11 Dyson fan, and the fan can be controlled via IR remote. So we're going to duplicate this remote essentially and hook it up with our system and have the fan trigger once the temperature in your room exceeds a certain level. So we're going to use a temperature sensor from the starter kit as well as the IR LED to make this project happen.
Okay, so it essentially turns on the fan when your room gets too hot.
Exactly.
Hey, that's
so
cool.
It'll create some airflow. Awesome. So yeah, we're using one client from the starter bundle as well as the Q server, of course. And then we're going to use the DHT11 temperature sensor.
Okay.
One IR emitter. 3 male to female jumper wires. And then approximately 7 male to male jumper wires as well.
Okay.
Oh, and the breadboard. You cannot forget that.
Alright.
So first we'll start by wiring up the circuit. As always, you can find all the parameters for the drivers used and wiring diagrams and breadboard schematics for both the IR emitter and the DHT11 on our Confluence documentation pages, which will be linked in the description.
Okay.
But yeah, let's get to wiring this. So first we'll start by wiring the DHT11, and we'll just set up the breadboard first. So we'll hook one male jumper wire from the 5-volt port on the builder base to the breadboard, and then we'll hook another male jumper wire to one of the negative rails on the breadboard, and then we'll just bridge these two rails in case we want to draw from either one. Then from here we'll put the DHT11 in the breadboard, and you can find this in the documentation, but the way it goes is this pin starting from the left is 5 volts, then it's the data, then this pin here is nothing, it's not connected to anything, and then the last one is ground.
Okay.
So we'll be following that wiring schema. So we'll start with the power. We'll simply connect that to the power rail.
Does this sensor only do temperature, or?
You can also do humidity with it as well.
Okay, cool.
But once you're building the firmware, in order to get both of those readings from the driver, you need to set up the temperature driver for that as well as the humidity driver. They're two separate drivers, but you can still take the readings from the same
hardware
sensor.
Yeah.
Exactly.
Okay.
The same time.
So at some point in the future, I might update my app and then just add the humidity part
later.
Yeah,
exactly.
as well. Nice.
Yeah. Okay. So now the DHT11 should be set up. We're connecting the data line to GP0.
And we could also use any of the other GPIO pins, right?
Exactly.
Yeah.
And then from here, actually, just swap out this wire.
And we're gonna put the IR emitter on the same client, right?
Yeah.
But we could also have the temperature probe like being placed somewhere else in our room, and then have the IR emitter.
Exactly.
The second client sit in front of the fan, right?
Yeah, precisely.
Okay.
Precisely. But this just makes it a smaller form factor, so it's easier to.
But we only do this on the table right now. But
exactly. Yeah. All right, so that's that. The DHT11, the data pin is connected to GP0. Now we'll move on to the IR emitter. So the way it's wired here, which you can also find in the documentation, is there's the signal pin on the left side, the middle pin is for 5 volts, and the rightmost pin is for ground. So we're just going to throw the male-female jumper wires on here. And we'll connect the signal line to the GP1 port. The 5-volt line to the 5-volt rail on the breadboard. And then the ground line to the ground rail on the breadboard.
Okay.
You could also connect it to the ports on the client or builder based, but this just makes things a little bit simpler.
All right, and this we arrange in a way so it's pointing towards the fan, right?
Exactly. So it's pointing towards the IR receiver on the fan.
Yeah. Okay.
So yeah. All right. So now we'll get to building the firmware. First, we suggest you power on the client and pair it with your system if you haven't already done so. So navigate over to the client's page and go to the unpaired section. Hit pair. And we always suggest that you identify your clients. You can see status blinking.
Yeah, that's the one.
Yep, and then we'll edit. We're gonna name this one DHT11 plus IR. So now we'll navigate over to our firmware section and we will hit the create new button. We'll make a new firmware called DHT11 plus IR. Here, we'll then add a temperature sensor or temperature device. We'll name this one temp. Then onto this device, we will select the DHT11 driver. The pin we'll use is GP0, and the resolution set in Fahrenheit is 1 degree. We selected GP0 just because that's how we wired it. You can use any other GP pin.
Okay, and I can also do it in Celsius if my system is set up in a different...
Right. So you would navigate over to the settings, and you can change your system settings.
Okay, to use a different measurement system.
Yeah, between imperial and metric.
Okay.
So now I'll add one more hardware device, which is the IR emitter. Name this one IR. And then from here, we'll just select the only driver available, which is the IR emitter. And then we'll assign it to GP1. So now this firmware file is complete. We'll save it. We'll go over to the actions button, upload it to your specified client. So now while this is uploading, we can build the application for this. We'll name this one fan plus temp. And we'll go to our hardware section and we'll select an IR emitter as well as a temperature sensor. So now we'll name both of these using the properties panel.
You could also have multiple temperature sensors, right?
Yeah, you could have multiple temperature sensors in different rooms, and each one of those temperature sensors could correlate to a different IR emitter, which would turn on a different fan.
Right.
So.
Or even the same fan, right?
Or the same fan. Yeah. Exactly.
Yeah. So it just depends on how we set it up in here.
Yep. So now that we have that, we're going to add a value compare block. This is the main logic in this app. Will be computed by this block, and we'll just call this one compare. So now we'll drag the temperature port to value 1 on the compare block. And then for value 2, we'll add an input text interface object, and this will allow us to set our temperature threshold. So we'll call this one threshold, and the label on this will be set temp.
And that would be in Fahrenheit then, right?
This will all be in Fahrenheit.
Okay.
Right. And so the value on temperature, value 1 will be set to trigger, so that every time a new temperature is sensed by the sensor or by the system, this compare will execute, and then it will determine whether or not the fan needs to be turned on.
Right. Which is nice because the app can just run it for itself, and you don't have to do anything because it's automatically doing it when it receives a new temperature measurement.
Exactly. Yeah. So we'll also add a button to the interface just to make our lives a little bit simpler, or not a hardware button, but an interface button.
Okay.
And we can just use this to then manually trigger the compare as well.
Okay.
So we'll just.
So in case we play around with the threshold and we wanted to compare and see if it does the correct thing.
Exactly.
Yeah. And this could also be a hardware button, right?
It could be. Yeah. You could also use a potentiometer or a rotary encoder instead of the input text, and you could use that to change.
Right, or a slider.
The temperature threshold, yeah exactly. Cool. So yeah, now that we have that set up, we will go and pull a static string from the code objects, and we will connect the greater output port from the value compare block to the trigger port on the static string block. And this static string is going to house our code for the AMS, or for the AM fan. So we already have the fan ready to go. We just found this one online. Now we also have an IR database that can be used with our system, but that's primarily for DVD players, TVs,
like multimedia
devices. Yeah. We don't have any codes for fans as of yet.
Okay. But we might add them at a later point. Yeah.
Once we find the right.
So I can also just like have whatever string that I might know and have it being emitted by doing exactly what you're showing right now.
Exactly. So now we're also going to add a text block, and this will just be linked to the temperature, so you get a sense for the temperature.
Okay.
And this we'll label this one current temp. Going.
Awesome.
Sweet. So yes, this should be good for the app. So yeah, the basic logic here, just before we start the application and map it, is the temperature is passed to the value 1 port, which is set to trigger. And we've set the threshold temperature to value 2. So now if the temperature sensed is greater than the value we've input for value 2, this string code object will be triggered, and that code will be sent to the IR emitter, which will turn on our fan.
Right. And what happens if the temperature, if it actually got cold enough and the fan has to turn off?
Well, the way we've configured it now, it won't turn off, but we could certainly incorporate some sort of toggle function.
Okay.
And we can make a secondary threshold. So if it's not within a certain range, either turn the fan off or turn it on. So yeah.
Okay. But we could add that at a later point. For now, we just want to keep our room cold when it's too hot. Okay.
Yeah,
cool.
When it's terrible heat. Okay. So now we'll go to mapping. Navigate to your fan application. Your temperature sensor device will be the DHT11, and your IR emitter will be the IR device on the same client.
You could essentially also use any other temperature sensor that our system supports, right?
Right.
You don't have to use the one that comes with the starter kit.
Exactly.
Yeah.
Exactly. Okay, so now we'll navigate over to the dashboard, and you can see here that the current temp in our room is 78 degrees. So now if we set the temp to 76 degrees and we hit this button, our fan should theoretically turn on.
Okay, let's try it. Oh, and it's turning on.
Turned on.
Nice. Okay, so that means you just put in a threshold which said, hey, if it's above 76 Fahrenheit, I want the fan to turn on in case the temperature is above those 76.
Exactly.
Okay.
Exactly. So it's doing that constant check.
Okay.
Also, so we triggered it using this button.
Right.
But if we waited long enough and there was a temperature change felt by the sensor, it would also trigger that.
Okay. Yeah. And then we can turn it off probably by setting the temperature to, let's say, 80, and then comparing it again.
Yeah. Well, no. We need to keep the temperature low, otherwise the value compare block won't actually trigger.
Oh, I see. Okay.
So, but if we just cycle this one more time,
okay, it should turn
off.
Okay, so that shows
that would be a secondary check
functionality
that we would need to add.
Okay, but that shows that you essentially can send the exact same code to turn off the fan again.
Exactly.
Yeah. Okay, so that's something to remember.
Yeah, for
each fan might work differently in that sense, but
yeah, for the Dyson fans, they don't seem to have any idempotent codes. They all are just the same code being sent each time to toggle it on and off.
Okay.
There is no on or off code for this.
Awesome. All right, Christian, thanks for showing us this project, and yeah, we hope we can get you guys in a cool environment with this, and yeah, we see you in the next episode.
Yeah. See you later, guys.
Bye.